Hello, and welcome to the last module in this semester. It's a long one. We do have to do all of these sections right in here in our Miller textbook. And the list of assignments looks like, wow, it's kind of daunting. 3.1, 3.2, again, 3.2, that's all exponentials. And then 3.3, 3.4, 3.5 is all logarithms. Actually, there's another 3.5 and a 3.6. So it's quite a lot of topics. Give yourself plenty of time, but it's a very important section. When we talk about the exponential and logarithmic graphs, they are inverses of each other. And hopefully in the first section, you will learn that a reflection over the line y equals x will give you an inverse graph for an inverse function here. So for example, if I just wanted to find the inverse of this point over here, it would be switching the x and the y. So you switch x and y and solve for y. And that's what's happening with these two functions. The reflection happens over that green line, but also we are switching the x and y and then solving for y. Exponentials are very important, especially with money. I think that's a pretty exciting thing to talk about. Like, for example, if you wanted to double your money. And in calculus, the calculus book will actually show you something called exponentiating both sides. That is not in our Miller text, and it's not in pre-calc. That's okay. So I want to show you those examples here at the end. So if you have these graphs on your calculator, e to the x and ln x are inverses. 2 to the x is just a different base than e. E is 2.718-ish. And then also log base, this is log base 10. So these aren't inverses, just the blue one and the black one are going to be inverses. So let me go ahead and turn these off for now. But I'm going to go ahead and do a zoom standard window to graph them. Zoom standard. And it doesn't look like they're inverses because I don't have a square window. I don't really have a 1-to-1 aspect ratio. If you want to do that, it's just a feature under zoom as well. So I can do a zoom square, which is number 5. And that gives you more of a 45-degree angle for the y equals x line. And they look more like inverses now. I use these as the captains of the team for the parent graphs. I think in pre-calc they might use 10 to the x or 2 to the x or log base 10 or log base 2. But these are the two most popular graphs that we use in calculus. Everything is E and everything is ln. If you graph the second one with a different base, you will see it's very similar, but not exactly the same. So they do have a horizontal asymptote of y equals 0, and this one's just going to be slightly wider. Same thing with the log. Log base 10 is different than log base e. ln is log base e. And that one is going to be slightly shorter. So it's interesting. Definitely play around with your graphing calculator to see the differences there. All right, let's talk about some of these examples that you might not find in ALEKS or in your textbook. A popular one is money, of course. And if you wanted to find out how to double your money, no matter what you have, and you could start with $1 or you could start with $1 million, doesn't matter, you're going to end up with a 2 here. So 2 is equal to the 10r, e to the 10r power. And when you have an exponent that you're trying to solve for up high, you want to take the log of both sides. It's best to use the same base that they're using here. So I'm going to do the ln of both sides. And that will, there's a property that says these two undo each other like inverses do. And then you will be left with just 10r. So an logarithm, an ln, will pull the powers down. There is a property that's going to pull the 10r out in front of ln of e. And ln of e is just a 1. So that's another way that you could look at that. But it's just a 10r, and that's equal to ln of 2. And then so our answer, ln of 2 divided by 10, is going to equal r. Of course, we're not sure what that is, so let's type that in. Okay, and ln of 2 is 0.69 something or other, and then divided by 10. So we're gonna need a rate that's close to 7%. But if you have a 7% rate for 10 years, you're gonna double your money in 10 years, which is kind of cool. That's kind of good to know. Another example, something that they don't teach. So again, that example 1 was just like this. You can pause the video and try that, but you're going to take the ln of both sides. And the answer for that one's going to be x is equal to the ln of 5. So take the ln of both sides, and x is equal to ln of 5. Type in that decimal. If you were to do the second one, we're going to do something called exponentiating. So I say if it's a log base 10, we're going to do 10 to the 10 to the. We're going to treat these both as exponents. Again, you're not going to hear some other book say that until you get to calculus class. So these two will undo each other because they are inverses, and basically the answer is 10 to the 5th, or a 1 with 5 zeros after it. In calculus, we do a lot of ln's, so I'll say e to the, 10 to the 10 to the, 5 to the 5, whatever the base is. So let's make example 5 have a different base. So this is log base 2. So then we'll 2 to the 2 to the. When we exponentiate both sides, we are treating both sides of the equation as chunk exponents. And the base, the exponential, and the logarithm, these two will undo each other. Don't cancel, but they do undo each other, and you will be left with an x on this side, and on this side you'll be left with 2x minus 3. Okay, there's other ways to do these problems, but I think exponentiating is the most efficient. So you can get started on your exponential homework. Reach out to Math Lab or to your teacher, or look on Khan Academy for extra help. Click on Alex examples if you get stuck. This is definitely something you want to master for your future, because the world works off of exponents and logarithms. Good luck.